Welcome to the DIY Honda Garage channel. Welcome to the diagnostic presentation for DTC P0100, which stands for Mass Airflow Sensor Circuit Malfunction, specifically tailored for the Honda CR-V models from 2023 onwards. The Mass Airflow (MAF) sensor plays a critical role in measuring the amount of air entering the engine, which the Powertrain Control Module (PCM) utilizes to adjust fuel delivery for optimal performance and emissions control. When the MAF sensor output frequency drops below a specified threshold, it triggers a fault, leading the PCM to store this diagnostic trouble code, DTC. This malfunction can have various consequences on engine performance, including poor fuel economy, rough idling, and decreased power output. We will delve into the error description, potential causes, and a systematic troubleshooting approach to effectively resolve this DTC. The mass airflow sensor is crucial for engine management. It accurately detects the volume of air entering the engine. This information is sent to the Powertrain Control Module, PCM, which adjusts fuel injection timing and duration to optimize the air-fuel mixture. The PCM is typically located near the engine bay inside the vehicle, and it interacts with several sensors, including the MAF and intake air temperature (IAT) sensors, to ensure efficient engine operation. If the MAF sensor's output frequency falls below a predefined value, the PCM identifies it as an abnormality and logs the DTC P0100. This can lead to various performance issues, underscoring the importance of the MAF sensor's functionality within the vehicle's engine management system. The possible causes for DTC P0100 include several specific malfunctions. An open circuit in VCC2, the power supply voltage circuit, can lead to insufficient voltage reaching the MAF sensor, causing it to malfunction. Next, signal issues in FGP, which denotes the frequency generator pulse sent from the MAF sensor to the PCM, could also signal a problem in communication between these components. Furthermore, the most common cause is a faulty MAF or IAT sensor. When these sensors do not function correctly, they cannot provide accurate airflow data, leading the PCM to register an error. Each of these components plays a significant role in the proper functioning of the vehicle's engine management system. The symptoms associated with DTC P0100 can significantly impact driving experience and vehicle performance. Drivers may notice poor fuel economy as the PCM struggles to maintain an optimal air-fuel mixture with inaccurate data from the MAF sensor. A rough engine idle may also be evident, as fluctuations in engine speed can occur due to improper air intake readings. Lastly, decreased vehicle power can lead to sluggish acceleration, making driving unenjoyable and potentially hazardous. These symptoms highlight the critical nature of the MAF sensor's accuracy and the implications of malfunctioning components on the overall engine performance. The initial step in troubleshooting DTC P0100 requires the vehicle to be turned to the on mode, which is crucial for the Powertrain Control Module, PCM, to initialize communication with the sensors. Once the vehicle is in the on condition, it is important to allow a wait time of at least 2 seconds. This pause ensures that all electronic systems and sensors are properly activated and can communicate effectively with the PCM. Failing to do this can yield inaccurate results in subsequent inspections, as the system may not be fully operational. This step is foundational to ensure accurate diagnostic readings. The next step involves a thorough inspection of the external circuits, specifically VCC2, SG2, and FGP. The VCC2 circuit is the power supply that feeds voltage to the MAF sensor, and it should be inspected for any open or damaged wiring that could disrupt power delivery. Similar attention is needed for the SG2 circuit, which is the signal ground. Ensuring it is intact is essential for sensor functionality. Finally, examining the FGP circuit, which carries the signal from the MAF sensor back to the PCM, will help identify any issues that could lead to incorrect data being transmitted. Each of these circuits must meet specific electrical resistance criteria, and any deviations must be noted as potential issues that could trigger DTC P0100. In this step, we focus on conducting thorough short-circuit tests on the FGP circuit. Begin by assessing if the FGP signal is shorted to ground. An acceptable reading should show more than 1 megaohm of resistance when the circuit is powered off. Conversely, if the test indicates a short to power, then this is concerning and signifies a fault that will need immediate correction. Conducting these tests helps in diagnosing the state of the circuit and determining whether the MAF sensor is functioning properly. These checks link back to the DTC P0100, as faults in these areas can directly lead to low or absent MAF sensor signal frequencies that prompt the error code. Next, we turn our attention to the MAF AIT sensor itself. Because there is no direct testing method available for the MAF sensor, the recommended approach is to replace it with a known good sensor. This step is essential for isolating the problem. If you install a functioning MAF sensor and the vehicle operates correctly without triggering DTC P0100 again, it indicates the original sensor was faulty. If the issue persists after installing the known good sensor, it suggests that other related components or circuits may be at fault. Being methodical in this approach helps to effectively narrow down the issue and avoid unnecessary component replacement. The final troubleshooting step is to inspect the powertrain control module, PCM. If all previous inspection items have shown normal conditions, it raises the likelihood that the PCM is the source of the problem. PMC, or Powertrain Control Module, is the brain of the engine management system, controlling various engine functions based on input received from multiple sensors, including the MAF. If the PCM is faulty, it may incorrectly interpret signals or fail to communicate effectively with sensors, thus triggering DTC P0100. Identifying a defective PCM is crucial, as it requires specialized handling and knowledge to replace or repair due to its significance in the vehicle's operability. After completing all the necessary repairs for DTC P0100, it is essential to perform a final verification. Begin by clearing the DTC using a diagnostic scan tool to reset the PCM. Following this, a test drive should be conducted to ensure the vehicle operates smoothly and that the error does not return. It is critical to monitor any sensor's feedback and check whether the MAF sensor's output frequency is now within the specified limits. If the DTC remains cleared following this test drive, it strongly indicates that the repairs were successful and that the vehicle's engine management system is functioning adequately. Preventive maintenance is key to avoiding DTC P0100 in the future. Regular checks on the MAF and IAT sensors can help catch any issues before they escalate into substantial problems, ensuring accurate airflow measurement is maintained. Additionally, maintaining clean air filters will prevent contaminants from affecting sensor operation and prolong the lifespan of the MAF sensor. Running maintenance checks at established intervals not only enhances vehicle performance, but also contributes to overall driving safety and efficiency. Protecting these sensitive components helps ensure that they operate within their specifications and can effectively communicate accurate data to the PCM. In conclusion, DTC P0100, which indicates a mass airflow sensor circuit malfunction, underscores the critical importance of both the MAF sensor and the PCM in vehicle performance. Through systematic troubleshooting steps, ranging from initial inspections to final verification, you can effectively diagnose and resolve this issue. Understanding the functionality of related circuits and components allows for a targeted approach in repairs. Moreover, embracing regular maintenance practices is beneficial in preventing the recurrence of this DTC and ensuring that your Honda CR-V remains in optimal condition. Together, this knowledge serves to empower vehicle owners and technicians alike, enhancing performance and driving experience. Please like and subscribe to the channel. See you next time.